Okay, so we're going to go over the homework questions from, what is it, 5-4C. This is page 230, numbers 2, 5, 8, 10. All right, some of these are a little tricky. Just taking a look at them. Let's start with number 2. Number 2, I hope you got, because this one's not too bad. I think all of you guys can do this one. It says, what is the largest possible area for a right triangle? So here's my right triangle, whose hypotenuse is 5, and what are its dimensions? Now, we're going to call this x and this y. We did one just like this, but the hypotenuse was 7. So really, you could just input 5 instead of 7. It's the exact same problem. So here we go. We have to maximize the area. So the area equals 1/2 base times height, 1/2 xy. And then Pythagorean theorem tells us that x squared plus y squared equals 25. So let's solve for y. Y would equal the plus and minus square root. We're just going to do the positive square root because y is the side of a triangle. 25 minus x squared. So our largest possible area is 1/2 x times 25 minus x squared to the 1/2. All right, so that's what we need to maximize. So let's take the derivative of the area. And this one's a little tricky derivative because we have a and we have b. And when we do b, we're going to have to do a chain rule on that one. Okay, so it's a times b prime. So I want to take the derivative of this right here. The derivative of that would be to take the 1/2 and move it down, leaving the inside alone, and then subtract 1 off the 1/2. So you get negative 1/2 up top, but then times the derivative of the inner function, which is negative 2x. All right, so that's just ab prime plus b, 25 minus x squared to the 1/2 times a prime, which is 1/2. All right, so let's fix everything here. I've got a 1/2 times a negative 2, or 2. So we'll get rid of that, and we'll rewrite this as, we have, what do we have? We have 1/2 x times negative x. So let's write that as x squared with a 2 on the bottom. And then this right here is 25 minus x squared to the negative 1/2 becomes the square root of 25 minus x squared on the bottom. And you're probably screaming at me right now, and you're telling me you forgot the negative, and you're right. Okay, plus 1/2. So the square root of 25 minus x squared, 1/2 of that. We're going to set this equal to 0 and solve. Okay, let's add this guy over to the other side so that we get the square root of 25 minus x squared over 2 is equal to x squared over 2 rad 25 minus x squared. And then we'll cross multiply here to get 2 times 25 minus x squared, because the rad times the rad just gives me the stuff inside, equals 2x squared. Divide both sides by 2. Oops, sorry about that. So now we have 25 minus x squared equals x squared. Add that x squared to the other side, so we get 2x squared equals 25. Divide by 2. X squared is 12.5, so x equals, and you can do this in your calculator, write it as a decimal, whatever you want to do. The square root of 12.5 is about 3.54. We'll round to 2 decimal places. Okay, so now we're going to go back up to here where y equals the square root of 25 minus 3.54 squared. And if I put that in my calculator, I'm going to do the square root of 25 minus my answer squared. That way I get a better answer, and as you know, you will get the exact same thing. It ends up being an isosceles triangle, where the two sides are equal to each other. So let's look back at what we need to find. So it says, what is the largest possible area and what are its dimensions? Well, the dimensions of this triangle would be a 3.54 by 3.54 by 5. You don't really need to write the by 5 because I already know that that's part of it. And then the area would be to do 1/2 base times height. So 0.5 times that answer squared. Let's see how that turns out. Oh, and when you keep that in your calculator, when you do 0.5 times that answer squared, you get exactly 6.25. So pretty. Okay, so that's the answer to number 2. All right, let's move on. Number 5. Number 5, this one's a little weird. It's not too bad as long as you can get the equation of that line, and that's probably what most of you guys struggled on. So this one has x and y axis, and it has a rectangle under here, and it goes like this, and then it goes over here like that. And my figure's not drawn to scale, and they say that's a right angle there. And so what they want you to do, and they label this as x, we're going to, letter A, express the y coordinate of P in terms of x. And it says, hint, write an equation for the line AB. This is the line AB right here. That's A, and that's B. So this goes through 1. Up there it doesn't say that it goes through 1. But this goes through -1, and it's a right triangle. So this is 2. We can find, oh wait, it says right here, whose hypotenuse is 2 units long. Perfect. All right, so there's a few things you can do to think about how, what this point is right here. Number 1, this is a 90-degree angle, and this is all symmetric, so this is going to be 45. This is 90, that would make this 45, and if you have 45 and 45, then that also is going to be a length of 1. Okay, so what you have here is you have 2 points. You have the point 0, 1, and then you have the point 1, 0. And you can write an equation of this line AB from those 2 points. But you can also see that the slope is down 1 over 1. Slope's -1. And the y-intercept is +1. So the equation of that line is y equals -x plus 1. Okay? So this line right here, AB, is -x plus 1. Now why did we need that? Well, because we need the height. And the height, remember when we did those parabolas, was always the equation of that parabola. Well, it's the equation of the line in this case. So let's see, we have this rectangle. Let's talk about this rectangle. The area is going to be 1/2 the base, which is 2x, times the height, which is -x plus 1. All right, so the 2's can reduce, and we're left with x times -x plus 1. Distribute that x to get -x squared plus x. This is an upside down parabola. It will have a maximum area. So take the derivative of the area and you get -2x plus 1. Set that equation equal to 0 and solve. So x equals 1/2. Now, I kind of jumped ahead. Oh, why did I write 1/2? Am I completely wrong? Yes, I am. It's not 1/2. Dang it. Can I rewind on this video? Were you yelling at me? You should have been. Erg. Sorry. Yes, I make lots of mistakes. We know this. And then now I'm trying to delete all of this. Not good. Sorry, kids. My bad. Okay. Let's start over. I'm glad I caught it, though. That would have been even worse, but it's still pretty bad. All right, so base times height. Area equals base times the height. No, 1/2. I was still in triangle mode. All right, so area equals negative 2x squared plus 2x. Take the derivative and you get negative 4x plus 2. Set that equal to 0 and solve. So 4x equals 2. Divide by 4. X equals 1/2. That's pretty funny. X equals 1/2. Neat. Okay, so that means that the base is 2x, so the base would be 1, and then the height is right here, the y, negative 1/2 plus 1, which would be 1/2. So you get base is 1, height is 1/2, so that's what the dimensions are. And what is the largest area? So you just multiply base times height. So the largest area would be 1 times 1/2, which would be 1/2 units squared. There you go. Nice. Okay, sorry about that mistake in the middle there, but we caught it. Okay, what's next? Number 8. Number 8, closing off the first quadrant. You're planning to close off a corner of the first quadrant with a line segment 20 units long running from A0 to 0B. Okay. Sometimes understanding the problem is the hardest part. So we're closing off this quadrant here with a line segment that is 20 units long. Okay. Now it could have been that. It could have been, you know, A was here and then it's 20 units long there. Or I could have had something like here, 20 units long. It would have been like here. So there's all these different triangles in here. Now, you probably know by now, and I know, that when I draw this one, I'm going to go over here, we always keep getting these like triangles that are the same side on each. And that's probably what's going to happen here too. No, spoiler alert. Okay, so we have, this is the point A0, and this is the point 0B. And we need to show that the area of the triangle enclosed by the segment is largest when A equals B. So yeah, I'm trying to show that this side equals that side. But guess what? It's just one of those same problems that we've already done today. And so I'm just going to say this is X and this is Y. I don't know that they're equal to each other yet, even though they told me they are. So we have two equations to set up. We have x squared plus y squared equals 20 squared. And then we have area equals 1/2 base times height. This is exactly like problem number, what was that problem, 2? Yeah, this is exactly like problem number 2, except instead of the hypotenuse is 5, the hypotenuse is 20. So I'm actually not going to do this one for you. You're going to do it. And I have, I think, another one for you to do on tonight's homework too. So by then you're going to be outstanding at these problems. All right, I'm moving on to number 10. Are you mad at me? Don't be mad. All right, number 10. The shortest fence. Okay. It says here, a 216 square meter rectangular pea patch, cute, is to be enclosed by a fence. And then divided into 2 equal parts by another fence parallel to one of the sides. There we go. What dimensions for the outer rectangle will require the smallest total length of fence, and how much fence is needed? We're going to call this X, and we're going to call this entire side Y. That means this is X, and then this is Y over here. Okay, so let's start with what we know. We know that the rectangle has an area of 216. So I can say X times Y is 216. Now I'm trying to minimize the smallest length of fence. My fence is going to go around the outside, and down the middle. So we need how many and how many? We need 2 Y's and 3 X's for this. And then we're going to have a perimeter that we need to minimize. All right, so here we go. We're going to solve for one of our variables. I'm sure you want to solve for Y here. So y is equal to 216 divided by x. So let's take that, plug it in. All right, so 2 times 216, 432. 432 over x plus 3x is equal to my perimeter. Okay, so now let's take the derivative. So the derivative is going to be, now remember, 432 over x is the same thing as putting that to the -1. So let's bring it down, negative 432, and then x to the -2, so x squared plus 3. All right, take that over x squared plus 3 and set it equal to 0. So we'll add that negative 432 over x squared to the other side. I'm gonna go over here. So 432 over x squared is equal to 3. And then cross multiply. Oh, this is so pretty. Cross multiply and you get 3x squared equals 432. And they were so nice to you. Can you tell that 432 is divisible by 3? Anybody know? Yeah, 4 plus 3 plus 2 is 9, and 9 is divisible by 3. Some things you just didn't know, or maybe I've already told you that 3 times. Okay, so you get x squared equals 144. Take the positive square root, and you get a perfect 12. Ooh, calculus goosebumps. Okay, so what's the question? Here we go. What dimensions and how much fence are you going to need? So the dimensions would be x is 12 and y is 216 divided by 12, which is 18. 216 over 12, which is 18. And we're in what, meters? Yeah. So this would be a 12 by 18 meter pen. And then the perimeter, well, you can find perimeter 2 ways. You can do 2 times y plus 3 times x, or I could have gone to perimeter is right here and just plug x in. It's whatever you want, it's fine. All right, so 2 times 18 plus 3 times 12 gives us that the perimeter is 72 meters long. Okay, and that concludes my session of doing your homework for you. Go back and do number 8. Bye.